Okay, this is the last of the videos for the expeditions. This is X.3. This is derivatives of inverse trig and inverse functions. So this was in the last unit. I did not have time to do it. This is on the AP test, but to be honest, pretty small percentage of it is on there. But this can often be like a free point when you're on the test. Like if you know these, um, you'll see them on the test. You get a free point. Um, so I guess like what are inverse trig functions to begin with? I think that's a good place to begin. Like what does that even mean? So let's draw a triangle, um, right triangle, and we'll call this theta, and we'll call this A, B, and C. Think about sine. So sine of theta would be A over C, opposite over hypotenuse. That is what sine means. What does inverse sine do? Well, you have the inverse sine, which is shown by this notation, although I'll show you a different notation in a second. You don't put in theta, right? You do not do this. What you actually do with inverse sine is you put in the ratio, so A over C, and it gives you back the theta, right? So in trig, you take the trig functions of angles to get you a ratio, and in inverse trig, you take the inverse function of the ratio to get the angle, right? To get the theta. That's how it works. So we don't use this notation that often. You'll see this notation, but this instead, um, what you will probably see more is arc sine. And just like sine and cosine, you always have to have a value in in the parentheses. It cannot be by itself. So that's just like a very brief overview. I will link you like more detailed videos on explaining these in the delta. But I'm just gonna give you the bare bones. What do you need to know, right? So what do you need to know? These are just new derivatives. That's what all I want you to know is like these are just new derivatives to memorize, and I'm gonna go through them. So first we have the derivative of arc sine x. Arc sine x is um, let's say the derivative, let's do it right. The derivative of arc sine x is 1 over root 1 minus x squared. Okay, then we have, make sure that's super clear. Then we're going to have the derivative of arc cosine x, and that is just negative 1 over root 1 minus x squared. Okay, that's it. Just add a negative. Remember, cosines are negative, right? Then we've got the derivative of tangent, so arctangent, which is 1 over 1 plus x squared. And then you have the derivative of arc cotangent, which is negative 1 over 1 plus x squared. Noticing a little pattern here? Okay, and then the last one, and these are very rare, but I will go over them. The derivative of arc secant is 1 over the absolute value of x times the square root of x squared minus 1. And then we have the derivative of arc cosecant, which is the negative 1 over absolute value of x root x squared minus 1. Okay, so you can see, you're memorizing, it looks like 6 derivatives. It's really just 3, right? And the main ones are really the ones at the top. I think you'd be fine if you just memorized arc sine, arc tan, arc cosine. Those are ones that you could see on the test, right, potentially. Um, and so again, like not very common, but can be a free point. Let's do a couple practice problems before we look at inverse derivatives. So here we go. Um, it can be as simple as this. Arc sine of 3x. What is the derivative? So remember, this is the same as arc sine, just want to make sure it's clear, right? That's the same as saying arc sine 3x. So the derivative of arc sine, so you can refer back to your notes, is 1 over root 1 minus x squared. So it's going to be 1 over root 1 minus quantity 3x squared. Now, because it's chain rule, you have to multiply that by 3. Right? So our final answer would be 3 over root 1 minus 9x squared if I were to expand that out. That's it. That's all it is. It's just another derivative rule. You can watch the other video to get like a more detailed explanation of how we get there, but that's all it is. This example is it's just written in a limit form. So you this is just a review from way back from one. This is nothing new. Is that when you see this limit form, you're just finding the derivative of this, right? It's just one. It's just the derivative of our cosine, and so that's -1 over root 1 minus x squared. That's it. Okay. So that's the inverse trig functions. Now we will do inverse derivatives. Okay. So okay, inverse functions. I have not covered inverse functions at all. I don't know if you've even learned inverse functions in your high school career, so it would be worth talking about them briefly. What are inverse functions? Well, inverse functions undo another function. So let's think about it like this. So let's say we had a function f of x equals 2x. Let's keep it simple. What that means is when I put in some number a, and I go through 2x, right? Um, I'm going to get some number b, which is going to be 2 times whatever a was. There is an inverse function to f of x called, we'll call it g of x, right? So let's say I have this function. We call it, the notation is this little -1, which I know is annoying because you think it means the negative first power. It doesn't. Let's call it g of x. And what g of x does, or what the inverse does, well, we can call it g of x. You can call it whatever you want. Is it'll take a b and give you a. And the cool thing is that when you composite these functions together, you will get x. So let's think about what is the inverse to 2x, right? If 2x is multiplying everything, well then the inverse of that would be having it. So in this case, my g of x would be x over 2. And when I take when I composite them together, right, you're gonna get 2x over 2, which is just x. Okay, so that's how inverse functions work. Inverse function is a function that undoes the other, that takes the value that you got and gives you back the original value. That's the long and short of inverse functions. Okay. So how does this work in calculus? Well, sometimes calculus will ask you to find the derivative of the inverse. So the derivative is just a formula. The derivative of the inverse of a function is equal to 1 over the derivative of that function with the value of the inverse put in. So in this case, remember that the derivative, the inverse, is equal to g of x. Okay, so you could think of this as like the derivative of g of x. Okay, if g of x is the inverse, then the derivative of g of x would be 1 over the original's derivative of the input of g of x. And I think the best way to really explain this is through a problem. So let's do that. Okay, so let's look at the delta problems. The function f is defined by f of x is negative 2x to the third minus x plus 1 at the point 0, 1. The point 0, 1 is on the graph. If g is the inverse of f, what is the value of g prime of 1? So I know that g is the inverse, so if I'm given that, I'm going to use my formula. So I know that g prime of 1 is going to equal 1 over the derivative of f at g of 1. Okay, so let's start filling this in. What is g of 1? G of 1 is 0. Because it's an inverse function, it is taking the y value and giving me back the x. That's what inverses do. They would take the quote y value and give you back the x. So this is the same as g prime of 1 equals 1 over f prime of 0. Okay. Well, then I just need to find f prime. Well, f prime is it's pretty easy. It's just a power rule. It's going to be f prime of x is negative 6x squared minus 1. So going back down, it's going to be g prime of 1 equals 1 over, and I'm just going to plug in a 0 this. It's going to be 1 over negative 1. Because I plug in a 0, that's going to go to 0, so it's just the answer is negative 1. That's it. So this is kind of the problem you just have to practice, right? It seems like kind of fairly weird, like kind of like riding a bicycle backwards. That's kind of how I would describe it. It's like this is weird, but once you get into the rhythm and you understand the formula and you understand how to apply it, then you'll get in the rhythm. You'll get it down. Okay. Um, Table below gives selected values for differentiable and decreasing function. If it's derivative of the inverse f, if the inverse of f, the inverse function f, what is the value of the inverse of f at 0? So the derivative of f inverse of f at 0. So we use the formula. The derivative of the inverse of f at 0 is going to be 1 over the derivative of f at the inverse of 0. And I know this looks confusing. There's a lot of symbols that look very similar. So I want to take it's going to be 1 over, well, what is the inverse of 0? The inverse of 0 means I go find 0 as an output and find its input. The inverse of 0 is 8. So what it's really saying is 1 over the derivative at 8. The derivative at 8 is negative 7, so it's 1 over negative 7. That is your answer. Okay. So what is the key? What is the hard part here? I think the easy part is memorizing the formula. I think the hard part is understanding what this value is. This value you obtain by going to the y and getting the x. That's how you do it. Okay. All right, look at delta, watch the videos I added.